Hey, and welcome. And in this video, we will be looking at matter. This is an introduction to chemistry, the first topic, I believe, in chemistry, even as you're introduced to this world of chemistry. And firstly, we need to know what chemistry is. When we talk of chemistry, we're simply talking of a branch of science that deals with the structure, composition, properties, and the reactive characteristics of matter. Okay, so chemistry is simply dealing with the structure, the composition, the properties, and the reactive characteristics of matter. It's a branch of science. So we've been learning about science from grade 1 to grade 7 to grade 8. But then when we come to secondary, we branch into the various disciplines of science. So one of them is chemistry, and chemistry deals with the properties, the structure, the composition, and the reactive characteristics of matter. So now, the word that stands out there is matter. So for you to understand what chemistry is and to really appreciate chemistry, you need to know what the word matter means. So what is matter? When we talk of matter, we are simply talking of anything that has mass and can occupy space. So the definition of matter is, let me just write it there for you. Matter is anything that, trying to write anything and that at the same time, anything that has mass and occupies space. Occupies space. So matter is anything that has mass and occupies space. So as a grade 10, as a grade 11, grade 12, grade 9, I believe you've come across the word mass before. And when people talk of mass, another word that is related to mass is weight. Now, these two are very, very diverse, very different terms, which mean totally different things. And I wouldn't want any of you to confuse mass with weight. So when we talk of weight is dependent on the gravitational pull of the weight is dependent on the gravitational pull on an object. So when we talk of weight is a property of an object and is as a result of the pull of gravity on an object. So the weight that you record here on Earth would be different as one that is recorded on Mars or on Mars, on Jupiter, on the Moon, and so on, because these places that I've mentioned have different gravitational pull. So if you were to take an object from Earth, measure its weight, take it to the Moon, measure its weight, take it to Mars, measure its weight, take it to Jupiter, measure its weight, you'd find that the weights are different. But on the other hand, when we talk of mass, we say the mass of an object is an inherent property, okay, and does not change regardless of the location, regardless of the gravitational pull, regardless of whatever. So mass is dependent on how much matter is in a substance. So mass is the same no matter where you measure it from. Okay, so key thing to remember is that matter is anything that has mass and occupies space. I haven't said that anything that has weight, but we have used the term mass. So matter is anything that has mass and occupies space. Another key point to remember is that when you talk of matter, matter is composed of substances known as atoms. So we'll get into knowing what atoms are in a later video. At this point, I just need you to remember to say matter is composed of atoms. So matter is anything that has mass and occupies space. Can you think of anything that falls under the category of matter? Can you think of anything that has mass and occupies space? Well, you yourself are matter because you have a mass and you occupy space. Your phone is an example of matter. Food is an example of matter. Juice is an example of matter. Water is an example of matter, and so many things. Almost everything that you can see and touch is an example of matter. So let's get into understanding what we are talking about. Let's get into understanding what we are talking about. So when we speak of matter, there are three states in which matter can exist. So there are three states in which matter can exist. Three states of matter. I believe you know this. The first state is solid. The second state is liquid. And the third state is gas. Okay, so these three states have their own properties and own characteristics, and we are able to identify these a substance either as a liquid, a solid, or a gas. At this level, this is all we have to know. And the state in which a substance appears or is being, the state in which a substance is can be due to, or rather is due to, the atmospheric conditions around that substance. Okay, so there are different things that affect the state in which a substance is exhibiting itself. The temperature, we've got pressure, we've got so many things. So we'll get into more details as we move on. But firstly, let us get to appreciate and be able to distinguish these three states of matter. So let's start with the first one, which is solid. So the first one, solid. So what are the characteristics of solids? The first one is that solids have a definite shape. Solids have a definite shape. So definite shape. This is definite shape. Okay, so think of any solids. Think of your shoes. Think of your laptop. Think of your phone. These have a definite shape. In short, they are rigid. These have a definite shape. You can think of your pencil. You can think of anything. These have a definite shape. If it's round, it's round. If it's rectangular, it's rectangular, and so on. So solids have a definite shape. The second characteristic of solids is that they have definite volume. Definite volume. So when we talk of volume, we're not talking about the volume that you add or you get from your TV and your radio, but we are talking of volume scientifically. Okay? Solids have definite volume, so we'll get to understand and appreciate volume later on as we move on. But for now, just understand to say solids have definite shape, they have definite volume, and apart from that, solids have their particles vibrating about a fixed position. So solid particles vibrate about fixed positions, about fixed, don't know what's wrong with my handwriting today, about fixed positions. Okay, so solids have definite shape, solids have definite volume, and solid particles vibrate about fixed positions. Let's get to liquids. When we talk of liquids, do liquids have a definite shape? Do liquids have a definite shape? Well, liquids do not have a definite shape, but instead they take up the shape of the container in which they are put. What do I mean? When you've got water in a glass, the water is in the shape of the glass. If you pour the same water into a container, the water will take up the shape of the container. If you pour same water into a very slender bottle, the water will take up the shape of that bottle. So liquids do not have a definite shape, so no definite shape. Are we together? So liquids do not have a definite shape. On the other hand, liquids do have definite volume. So liquids have definite volume. So this is one thing that they have with solids, definite volume. Then another thing about liquids is that liquid particles are free to move over each other, but they are still attracted to each other. So what do I mean? Liquids particles are free to move over each other, while solid particles vibrate about a fixed position. The reason why you're able to, let's say, move water from a bottle to a cup is because the liquid particles are able to move on top of each other, and so they are able to flow in that way. You understand? So unlike solid particles, liquid particles are free to move. Particles are free to move over each other. Now let's go to gases. The third one is gases. So when we talk of gases, do gases have definite shape? No. Gases do not have a definite shape. So no definite shape. No definite shape. Definite shape. Apart from that, gases do not have a definite volume, so no definite volume. Definite volume. Then apart from that, gas particles are able to move in any way. They are able to move in random motion, and they are not attracted to each other. So particles are free. These ones are just free particles. Particles are free. And gases have another characteristic which is unlike any other state of matter. And that characteristic is that gases are compressible. What do we mean when we say gases are compressible? I believe most of you can ride bicycles, or you've played football before. You know that pump that we use to pump air into bicycle wheels or into footballs or rugby balls and so on. That pump contains gases, or contains a gas. And so the reason as to why you're able to draw gas and then push it inside is because of the compressibility of gases. If you had water in the pump and you'd try to compress it, you'd find that it would be really, really difficult to compress. So we'll get to understand more about this later as we move on. So in summary, on the states of matter, there are three states of matter in which it can exist. There are three states in which matter can exist, rather. That's solid, liquid, and gas. Solids have a definite shape and they have a definite volume. Liquids have definite volume, but liquids have a definite volume, but they take up the shape of the container in which they are put. Or gases have no definite shape, they do not have definite volume. So that's that about the states of matter. Now I mentioned to say substances can exist in all three states of matter. Let's get rid of this. Substances can exist in all three states of matter. What do I mean? Let's take water as an example. Water can exist as a solid, as a gas, and as a liquid. So water can exist as a solid. How does water exist as a solid? Water exists as a solid in the form of, yes, in the form of ice. So if you were to take water, place it in the fridge for a very long time, you'd find that the liquid water has hardened and it is so hard as a rock, and it is in the form of ice, and that is a state known as solid. So water can exist as a solid in the form of ice. It can also exist as a liquid as water. So it exists as a liquid as well, water. And it can also exist as a gas. How does water exist as a gas? Take water, place it on a stove, crank up the heat, and you find that it will start boiling. As it's boiling, there will be a certain gas that will be released, some vapor to be released, and so water has just changed from the liquid that it was to gas. So it can exist in the form of gas as water vapor. Okay? So substances are able to exist in all three states of matter. Now these changes from one state of matter to another state of matter to another state of matter are what are known as physical changes. These are what are known as physical changes. So let's talk about physical changes or physical change. Let's get an idea, let's get to know what physical change is. So let's go back to the water example. So we say we have ice. If that ice is left if we just leave the ice, let's say on the ground, we'll find that it will melt. And upon melting, it will change from the solid that it was to liquid. And later on, we'll find that it will evaporate and it will change from that liquid phase or that liquid phase to a gaseous phase. So this melting of ice is an example of what is known as physical change. So a physical change is a change to a sample of matter, a substance of matter, in which some properties of the material change, but the identity of the material does not. So that ice that you had was water. When it melts, it will change to liquid, but it will still be water. So we find that the properties of that material have changed, whilst on the other hand, its identity still remains the same. If it was water, it will still remain as water. Okay? So now physical changes can be classified as reversible and also as non-reversible or as irreversible. Okay? What do you mean by reversible and irreversible? Let's say we have water in a container, put it in the fridge, it freezes and it becomes so hard, it turns into a solid. If we were to take that water out of the fridge, put it on the ground for some time, we'll find that it will change back to liquid. So physical changes can be reversible or irreversible. So let us just write down what we've learned about physical change. So in talk of physical change, we are saying identity remains the same. So in talk of identity remaining the same, we are talking about the substance that you started with will be the substance that you still have even after undergoing a physical change. If you had water that was frozen, once it changes to water that is liquid, the water will still be water. Water won't change from water to juice just because you put it in the fridge. Or juice won't change to beer because you boiled it and it's changed to vapor and it changes to beer. But no, the identity remains the same in physical change. But what changes are the properties. So properties of the substance change. properties change. Apart from that, we've also learned to say physical change can be reversible or irreversible. Can be reversible or irreversible. Okay? Okay. So physical change, the identity remains the same, the properties change, and it can be reversible or irreversible. So now let's look at examples of physical change. So when we talk of physical change, we've talked about water being, we'll stick to the water that we've been talking about, and we've said to say water can change from liquid to gas, it can change from solid to liquid, can change from liquid to solid. Okay, so when you talk of a change from, so we've got, let me just write this here, we've got gas here, then we've got liquid, and then we've got solid. So when a gas changes from, let's start with a liquid. When a liquid changes to gas, let's say water is put on the stove. Water is put on the stove and it changes from liquid to gas. What do we say the water has done? We say the water has evaporated. So this is known as evaporation. I believe this is a term that we are familiar with as grade 10s or grade 9s or grade 12s. Evaporation. So when a liquid changes from liquid to gas, we say it has evaporated. Then there's a change from solid to liquid. When a solid changes from solid to liquid, what do we say? When we have ice put in the fridge, then we remove it, and then it changes from the solid ice to liquid water, we say it has melted. So this is known as melting. Okay? What other change do we know? What other change do we know? If a liquid changes from liquid to solid, what do we call that change? When you have water, place it in the fridge and it changes from a liquid to a solid, what do we say it has undergone? We say it has undergone freezing. So this is known as freezing. This is known as freezing. So we've got evaporation, freezing, and melting. Which other change of state do we know? If a gas changes from gas to a liquid, what do we say it has done? We say it has undergone condensation. I believe this is the one that might seem as a new term. Condensation is simply the change from gas to liquid. Okay? Then we can look at one last change, which is from gas directly to solid without passing through the liquid phase. And this change is another new word known as sublimation. I believe things are getting interesting now. So we've said from liquid to solid, it's freezing. From liquid to gas, it's evaporation. From gas to liquid, it's condensation. And from solid to liquid, it's melting. And lastly, from gas to solid, it's known as sublimation. Okay? So I want to give you time to process all this. I want you to look at this. If possible, you can write it down and you can look at it as many times as you can, just so that you can have this information in your head and you can know what evaporation is, freezing is, melting, condensation, and lastly, sublimation. Okay? So as I said, changes can be reversible and or they can be irreversible. So when we talk of reversible changes, we can talk of salt being dissolved into water. Okay, so when you dissolve salt into water, do you know that you can actually get back the salt that you had placed in the water after dissolving? Well, if you didn't know, now you do. It's possible that you can get salt that you had dissolved into water back and the water have it separately in another container. And similarly, if you are to dissolve sugar into water, you would separate the water and the sugar. So that type of change is known as a reversible change. Okay. Then when we talk of irreversible change, we can talk of when a piece of wood is being turned into sawdust. That change is a physical change, but on the other, unlike sugar dissolving in water, it is quite irreversible and cannot have the wood that you had from the sawdust that you have now. Okay, so that is that about physical changes. Physical changes is simply the change in the properties of a substance. The identity remains the same and can be either reversible or irreversible. And we've talked about the change of states from, let's say, gas to liquid. We said it's known as condensation. From liquid to solid, we said it's freezing. And from solid to liquid, we said it's melting. And from liquid to gas, we said it's evaporation. And the new word that we've learned is sublimation. Sublimation is simply the change from gas to solid. So that's that about physical change. Let's look at chemical change. So let's look at the next type of change, which is known as chemical change. So we will not talk so much on chemical change because this is where we will be going, and you understand more about chemical changes as we move on. So here I'm just going to give you a rough picture of what chemical change is. So in talk of chemical change, physical change, we said no new substance is formed, so the identity remains the same. Nothing new is formed. If you had water from the beginning, you still have water at the end of the change. But on the other hand, when we talk of chemical changes, in chemical changes, the identity of chemical changes is that in chemical changes, new substances are formed. New substance formed. So if you had, let's say, water, after a chemical change, you won't have water, you have milk, you have juice. And in fact, that's a very perfect example when you have water and you have some juice. When you mix the two, you won't have water and juice, but you have a new substance that will be formed. Okay, so many examples of chemical changes. Let's talk of rotting. When you have bread that has been in your cabinet for a very long time, you find that that bread after some time will no longer be bread, but it will be a different substance, and it's very difficult, nearly impossible to get that initial bread that you had back from that rotten substance, new substance that you have now. Okay, so what characterizes the change, chemical change, is that in chemical changes, one or more substances are changed into one or more new substances. So chemical changes are also known as, this is AKA, also known as chemical reactions. So chemical changes are also known as chemical reactions. Why? Because there's a new substance that is being formed from totally different substances. Okay, so a chemical reaction can have, let's say, two substances mixing. Let's say, for example, you'd have substance A mixing with substance B, and this is giving you a new substance, substance C, okay? Substance A mixing with substance B, giving you a new substance known as substance C. So these substances on this side are known as the reactants, and this substance that has been formed this side is known as the product. So don't get lost here. We'll get into understanding what reactants, what products are in coming videos. This is just me laying a foundation for where we are going. So a product is simply a substance that is present at the end of a chemical reaction. A chemical reaction is a chemical change, while a reactant is a substance that is present at the beginning of a chemical reaction or a chemical change. Okay, so we'll get into understanding chemical changes as we move in this course, and I believe we can end here for now, and hope to see you in the next video. Hope to meet in the next video. In the next video, we'll take a deeper look into matter. We'll look at pure substances, we'll look at mixtures, we'll look at homogeneous mixtures, heterogeneous mixtures, and we'll gain understanding on the different types of states, on the different types of states of matter. Yes, let's say that. We'll look at chemical compositions, we'll look at pure substances, and so on. So can't wait to see you, can't wait to interact with you, and thank you very much for watching this video, and goodbye.